So final tips. Of course, this contained loads of information. Here's a couple final tips. When to invert a circle or line, when a circle or line is tangent to another circle or line, the tangency remains under inversion, and in addition, when two circles or lines are tangent at the center of inversion, the image is a pair of parallel lines. Another case is where several circles pass through the center of inversion. We can map these circles to lines, giving us something we can easily deal with. And then overlays or inversions that map an entity to itself. The orthogonal circles and root BC lemmas are examples of these. They're called overlays, and they're very useful. So, and also anytime you see that any of the lemmas presented in this lecture prove to be fruitful when we invert through a specific point in a problem, if you see it could be helpful, just definitely try it out. Like for example, when we see triangle ABC and an angle bisector, using our force overlaid inversion will probably be helpful. When we see orthogonal circles, you might want to try inverting those, and then we have those other lemmas, 8.9 to 8.11. So yeah, don't forget those lemmas. When not to invert. When angle conditions are defined in several places, including those that don't contain a ray connecting a point to the center. Angle conditions end up useful only when the center of inversion lies on one of the rays defining the angle. So yeah, that limits it quite a bit, but hopefully you don't see too many problems with very scattered angles. And when there's a lot of lines and very few circles. Now, for this, actually, projective geometry will turn out better to handle these, and hopefully you'll learn about that in a future lecture. Or if you just can't, you can angle chase. But yeah, you just can't invert those problems. Just gonna overcomplicate it. You're gonna invert all those lines to circles, and oh, that's gonna be a nightmare. And yeah, summary. Inversion maps points to other points such that the product of the distance from the center to each point is equal to that of the square of the radius of inversion. In particular, points on the circle of inversion remain fixed. Go to slide 3. Circles and lines are sent to circles and lines, slide 5. Some angle conditions are induced as well, slide 4. Tangency and intersections are preferred, slide 6. Several lemmas are important inversion should be kept in mind. Yeah, like I just said. And you can view them at these slides. Thank you. Credits to Chevin N, the man who made all the handouts I've linked in this lecture. AGMO is a very helpful resource. You can also check out his handouts on his site. But overall, a big thanks to him for giving me knowledge of inversion and being able to present to you guys. Don't forget to join CNCM's Discord server. I've had a good liking to CNCM. They're a very helpful community, and I've developed some great friendships with the people in there. You find people with the same interest of you in math. So yeah, and that's all. Thank you for watching.